In this video, we are going to find the global maximum and minimum values of the following function, and we are restricting ourselves to the closed interval from 1 to 4. The strategy that we're going to use here is often called the closed interval method. So the first thing we are going to do is we are going to find the critical points of our function, and then once we find those, we are going to compare the values of the function at the critical points as well as at the endpoints of the interval. So let's start by finding the critical points. To do that, we will take the first derivative. I'm just using the power rule to get this, so I have 6x to the 5th minus 30x to the 4th plus 36x cubed. This derivative is defined for all real numbers, so the only critical points that I will get are the ones where this derivative is 0. So what I'm going to do first is I'm going to first factor this so that I can easily determine what the roots of this polynomial are. So I can factor out a 6, and I can factor out an x cubed from each of my terms. It's okay if you do this in multiple steps or in more steps than I'm doing. So my first term, I'll be left with x squared. My second term, I am left with minus 5x, and the last term, I am left with just 6. Okay, and so now I have the 6x cubed still. The quadratic that's in parentheses, I can easily factor, so this is x minus 3 times x minus 2. So I needed two numbers that multiplied to give me 6, but add to give me negative 5. So that's how I got the negative 3 and negative 2. So this means we'll have critical points at x equals 0, x equals 3, and x equals 2. We now just want to be careful that we are looking only in our interval. So we want the interval from 1 to 4. Looking at our critical points, 3 is in that interval, 2 is in that interval, but 0 is not. And so we will not consider the critical point at x equals 0 for this problem. So this is not in the interval. And again, the reason I am excluding that from my next computation is because I am only concerned with what is the global maximum and global minimum on this specific interval. So you always have to be careful, double check that you are looking at values only within the interval that you're interested in. Okay, and so now we're going to evaluate our function so we're going to do this at 4 points. So we'll use the critical points that are in the interval and also the endpoints. So it will be at x equals 2, 3, 1, and 4. It doesn't matter what order I write this in because in the end I'm just going to be comparing values. Okay, so let me start with f of 2. So I'm plugging 2 into my original function, not into the derivative, so be careful with that. So this will be 2 to the 6th minus 6 times 2 to the 5th plus 9 times 2 to the 4th minus 1. And when I did this, I obtained 15. We'll now evaluate at 3, so that is 3 to the 6th minus 6 times 3 to the 5th plus 9 times 3 to the 4th minus 1. And when I did that, I got negative 1. The other two values are 1 and 4. So f of 1, I'll have 1 to the 6th minus 6 times 1 to the 5th plus 9 times 1 to the 4th minus 1, which gives us 3. And lastly, f of 4, so the right endpoint of my interval. So I'll have 4 to the 6th, that's a large number, minus 6 times 4 to the 5th, also a large number, plus 9 times 4 to the 4th, again, a large number, minus 1. But overall, what does that turn out to be? It turns out to be 255. Okay, so once we compute those values, the last step is we just look at them. So we have 4 different values of the function. The lowest value that we see is our global minimum, so we see a -1. So the minimum value of the function in the interval is -1. The largest value we see is 255, so that is the global maximum value in the interval. And then that's it. So now we just need to write up our conclusion. And so we could say the global minimum value of f is -1, and maybe we want to indicate where that occurs. So this occurs at x equals 3. And the global maximum value is 255. And where does that occur? That occurs at x equals 4. One thing I want to clarify here is that when I say the global minimum value, I'm always talking about values of the function. So I'm not talking about the x value. So things like global minimum value, global maximum value, that is looking for values of the function. But we can also say where that occurs, although that's not important for this problem. Okay, and so that is it. We have determined the global minimum value and the global maximum value. And maybe we should specify that this is all in the interval from 1 to 4. Okay. Some things I want to point out. So first off, one of those values, so the global minimum value, occurred at a critical point, whereas the global maximum value occurred at one of the endpoints. So you can have any combination of those things, really. So you could have them, both the min and the max, being at critical points. You could have them both being at the endpoints, or some sort of mixing and matching. Okay, the last thing I want to do in this video is I want to show you the graph of that function. So even though we can get our answers just computationally, it's always nice to get a visual after that. And so here is the graph of the function. So I'm just showing you the graph on Desmos.com. And so we see here that within our interval, so again, we're just looking from 1 to 4, our minimum is at x equals 3. And the scale on the graph, it's a little bit hard to see what's going on, but we know that that is the value, or that value is -1. If we had made our interval larger, we would have had a second global minimum value at x equals 0, because those points are at the same height, so they both have a value of -1. But since our interval started at 1, then we're not going to, that's why we did not include that other critical point. Okay, and because it's hard to get the scale right on this graph, we can't actually see right now where the point is when x is equal to 4, because that y value was so large. We can definitely tell that it's going to be the largest value, but maybe let's scroll out a little bit. I have to keep scrolling because remember that y value is at 255, and we see that it's all the way up here. So that endpoint definitely gives us the global maximum in our interval.